What's going on, John?
We're not live yet. Well, watch YouTube.
Johnny now.
What's going on, everyone? Johnny B. Crazy here, and welcome to another Nooners of Ice and Fire special edition with geophysicist Milt K and my co-host MackenzieLBurns. We'll be talking about the geology of Winterfell today and whether or not there's a super volcano underneath it or something of that nature. Would you go ahead and like to introduce yourself, Mackenzie, and then take it away, Milt K, if you like.
Well, you all know where to find me because I'm always with Johnny at pretty much any time of the day, besides today of all times, or earlier today. But I have a channel, and on that channel, I post Game of Thrones videos, and also have been doing a live stream series where we go through each episode of Game of Thrones, episode by episode. A few days ago, we did Season 1, Episode 1, Winter is Coming, and our next episode will be The King's Road. And yeah, that'll be, I don't know when, but it'll be very soon. And go ahead, Milt.
Yeah, guys, it's Milt from the Citadel Trivia. Just wanted to say hi to everybody, and basically wanted to talk about basically the natural history of Winterfell. I'm not here to disprove any theories yet, so we can hold off on the super volcanoes later, unless Johnny really wants to ask about it, during the presentation. But it's really more about the geologic history of Winterfell, how it formed, and what we can gain from the types of rocks that are built there, the presence of caverns, and basically the presence of hot springs. I did this same kind of presentation about maybe 10 months ago, so I figured it was time for a rehash since we did the Doom of Valyria presentation last week. Let's just go ahead and finish off part 2 on this geology series, if you will. And we all know that everybody loves the Stark, so it's a matter of interest to a lot of people. Anyway, to get started here, just wanted to acknowledge the same people as we did in the Doom of Valyria talk. Basically, Miles Trier, the guy from Stanford, who did a lot of work on building these geologic models of Westeros and Planetos. The Atlas of Ice and Fire blog, basically still a couple pictures from their blog, and of course various web sources for figures who shall remain nameless because I have no idea who did them. And here's the picture of basically Stannis getting ready to fight the Battle of Ice. That's gonna hopefully occur in the Winter's of Winter before I die. And the other picture is just a bunch of baboons kind of chilling out in a hot spring, and hot springs are really important in Winterfell that I'll discuss later on. So what are the facts of Winterfell? And these are basically just statements and observations taken from the book itself. First of all, that Winterfell is a very large castle, obviously. It's located in the center of the north, as shown by this little star here. And it was built roughly 8,000 years before the events of Game of Thrones. That's basically at the beginning of the Age of Heroes, if you will, or at the end of the long night. It's basically protected by 2 massive walls. Upper right hand corner shows kind of like a model of Winterfell. You basically got an outer wall composed of granite and an inner wall composed of something called a gray rock. And we'll get into basically the origins of the gray rock as well as the granite and how it kind of fits into the geologic models and how they form. Basically, the second observation is that there are winding tombs below the castle. We call them the crypts of Winterfell. And lastly, Winterfell, the castle itself, is situated atop hot springs that keep the castle warm even in winter. So there's some kind of basically a plumbing system that Winterfell has that basically takes advantage of the hot circulating waters that keep the walls heated up, and the floor is probably heated up as well during the winter time, making it a pretty nice place to live, even if the rest of the north is pretty cold. And you kind of see a little pond here and that's in here. That pond is actually not a hot spring. It was actually described in the books. I think the first Caitlin or the first Ned chapter that describes this, but I just like the picture because it's pretty. And then, you know, we saw the same scene in episode 1, season 1. And of course, for scale, you have the village idiot in the background who shall remain nameless, but we all know who that village idiot is. So, anyway, let's go ahead and talk about the granites first. Granites is a type of rock that's very coarse grained, meaning that there's really coarse crystals in it. Everybody's familiar with granite because, you know, modern day kitchens tend to have granite countertops in it, so everybody knows what it looks like. Essentially, if you remember back in the Demon Valera talk, I keep on talking about the subduction plate model, right? Where in a subduction zone, you have basically an oceanic plate that basically slides underneath another lower density plate called the continental crust. So you basically have a lesser dense oceanic crust basically subducting underneath a higher density oceanic crust sliding underneath a lesser density, lower density continental crust. And basically what happens is that the oceanic crust melts as it gets down deeper. Then basically the fluids themselves, the melt actually rises up, okay, which is lower density versus the surrounding rocks, and then basically forms volcanoes. Granites are actually called intrusive because they don't form outside of the Earth's surface. Like a volcano will blow up ash and everything else. That's referred to as an extrusive igneous rock, right? It's like when you pop a pimple, all that shit that comes out is extrusive, right? To put it mildly. Intrusive rocks are actually formed in the subsurface where it doesn't cool as fast, and because it doesn't cool off as fast, it actually builds bigger crystals in the rock. And how it forms is basically, look at the slide on the upper right. They actually get exposed by erosion. So you basically have magma rising up, it cools and solidifies, okay? And then, you know, over time, right, all the overlying layers will get eroded off, and basically you expose this big piece of cooled, slowly cooled, large crystalled rock, and that's called granite. Okay, the Sierra Nevada in California, if you're familiar with that mountain range, there is one big gigantic granite pluton or batholith, as well. So those mountains, they're solid granite, and it's basically been exposed over time. Those things formed like 260, 270 million years ago. So that's what granites are essentially, and how they form. Now, so what can we gain from this in terms of Winterfell itself? Well, they have granite there, so we know that granite must have been close by, because I searched it out 8,000 years ago that there was some sort of transportation system, like any kind of trucker union or railroads that basically sourced granite from, far away. So they probably had to go close by. They found some granite, basically made a quarry out of it, and basically dragged the hunks of granite to Winterfell to build a wall. And the nearest mountain range we have are basically the nearby Black Mountains that we see to the north. Is essentially, it basically spans from the Wolf's Wood up north into the beyond the wall. It's a big mountain range that you've seen in other maps. And you kind of see the pictures of the granite itself. I mean, not all granites look alike, but you have a close-up here of kind of like the fabric of the rock, and then what it's used for to build walls. That's an example of a granite wall. Okay, so let's get into my favorite thing, which are limestones. So the limestones is what I think is the gray rock that everybody talks about when describing the inner walls of Winterfell. And basically, it's kind of the same story as granite, right? It must have been a source very close by because of the lack of transportation. But the cool thing about the limestones is that these limestones are actually biochemical sedimentary rocks, meaning that they are formed by living organisms, right? And here's a little map of kind of like the carbon cycle. You basically shoot a bunch of CO2 up into the air. Then the CO2 basically forms into carbonic acid. It falls down, rains down to the ocean. Okay, and then it gets mixed around in the ocean. Organisms such as clams, sea snails, any kind of crustaceans will actually absorb this carbonate material and basically build shells out of it, out of calcium carbonate. And then when they die off, all you're left with is the shell die. The actual organism gets chewed up and eaten up, right? The flesh, and all you're left with is basically shells. So essentially, that's what limestone is. It's formed by various shell fragments of various sizes. It can be very microscopic in nature because it's not just sea snails that or crabs or whatever that actually form these calcium carbonate shells, or coral reefs is another thing. I mean, it could be really fine, really microscopic creatures that actually use this secrete the calcium carbonate making shells. Anyway, in order to actually create this stuff, basically the water can't be dirty, right? Because every time you find coral reefs, it tends to be very, very clean blue waters, right? You don't find coral reefs or any kind of massive carbonate communities, in really dirty waters, say like the Gulf of Mexico. I mean, you have little patch reefs, but you don't have these big, massive reef builders, sort of like what you have in the Great Barrier Reef of Australia. So it really does require a very clean water. Otherwise, the organisms will just die out, right? It's just too dirty. And it needs to be pretty shallow because it also needs light, right? In order for coral reefs and to grow, you're going to need, very shallow water, a lot of light, right? Required for the photosynthesis of these organisms. These limestones, the classical limestones also form, basically in warmer temperatures with a specific pH range. And usually, if you look in the map in the upper right-hand corner, it's generally between 30 north and south latitudes in the ocean, in the world. So you kind of see that little pink band here in the upper right-hand corner, where you see a lot of these large carbonate reefs and being developed. Okay, you don't see much stuff because otherwise it's either too dirty or it's just really too cold, or the water is just really too acidic. Okay, there are things called carbonate marl stones that basically can accumulate in deep water as fine-grained calcareous ooze, but those aren't classically defined as quote-unquote limestones. Okay, they can be called marl stones, if you will. Anyway, so getting back to what Winterfell is, the carbonate sediments themselves commonly produce gray-colored rocks. So, perhaps, the gray stone that make up the majority of Winterfell structures are these kind of, fine-grained gray rocks, if you will. A lot of times when you go into if you're hiking around any national forest region, climbing up rocks, you probably see a lot of stuff that looks kind of beigeish, kind of reddish. A lot of that's probably sandstones because they contain a lot more iron. But a lot of the gray stuff that you see, especially ones that are really, if it's not shale or anything like that, if you see fossils in them, if you see kind of like, shell fragments or whatever, or they tend to be more limestones. And a way to figure out what a limestone versus a shale is, basically, all you need to do is just drop some hydrochloric acid on it. And if it fizzes, then it contains a lot of carbonate. So anyway, so here's another example of a wall that's in Dublin, Ireland, and that one's made out of limestone. Pretty cool. So any questions about the rocks before I move on to some other stuff about Winterfell?
No, I just think that's really cool about the Greystone, and it's a very interesting topic. I'm just kind of lost in all this knowledge right now. So
yeah. As you go further on, you can I'll summarize and I'll integrate everything. Everything comes together at the end. But just remember that keep that subduction model in mind, because it's really important when we try to reconstruct the history of the area and what things are doing on a big scale. So the second observation that we have are these winding tombs underneath Winterfell, and what exactly are they? All right. Well, if we have a carbonate environment, okay, as it gets exposed, what happens is that we get this process called karsting, and you see this quite a lot in the United States, especially in Florida. You develop these sinkholes, which are basically dissolved limestone, right? Because once you have fresh water intruding onto a calcium carbonate rock system, you're basically going to dissolve it essentially because it's too acidic for the rock. And this karst topography manifests itself like in this kind of like the Swiss cheese geology, where you have surface water intruding into it and forming these very complex cave systems. And a good example of that is like Carlsbad Caverns in New Mexico. That's basically a type of system where the limestone itself basically is being continuously dissolved, forming these caves due to the influx of meteoric fresh water. And you look at that map in the U.S., you can see there's a lot of areas where we have these systems in place, and they can wreak a lot of havoc, right? It causes basically big sinkholes, stuff like that. So generally they're formed, in predominantly limestone type of environments, or where you have the limestone basement, if you will. And the thing about karsting too is that it initiates once limestone exposed to fresh waters, okay? Because limestone forms on basically ocean water, but once you get fresh water circulating through the system, you're going to start to dissolve the rocks and basically develop these caves. And an idea is that we see all these caves and winding tombs in Winterfell. We know that there has to be some limestone close by for them to build the walls. Perhaps Winterfell is sitting on karst topography. And here's an example of a kind of a cliff here where you kind of see this kind of network of caves in cross section on the face of the cliff. And perhaps, Winterfell may be sitting on top of it, and the things below it are what we call the crypts of Winterfell, these big, massive, winding cave systems in there. And so that's an idea, and it could be supported by what we know of basically the rocks and the carbonate environment that we're basically sitting on limestone essentially, and these caves are still actively growing, if you will, and they extend down for probably hundreds of feet. And no, I don't know if there's a dragon living in these caves, because that's one of the theories floating out there, is that there's what happened. The story goes that when Prince Jacaerys Targaryen went to Winterfell to basically ask the Starks for aid during the Dance of Dragons, his dragon Vermax basically went in one of these caves and basically laid a clutch of eggs. Okay, one of the eggs hatched, and now there's a dragon. They're heating up the waters, circulating in the caves, and that's the source of your hot springs, if you will.
What dragon eat?
Rats, maybe? I don't know. I mean, yeah. Yeah, rats. I don't know. People throw these theories, and without any real proof. But it sounds neat, right? That there's a dragon down there that's basically warming up the waters. But realistically, is it possible? Probably not.
I mean, I wasn't joking when I was asking if there was a volcano under Winterfell, but you're kind of blowing me to pieces here. This is
okay.
Very.
Well, the only thing I can say is that there is definitely a network of caves, because that's been observed in the books, caverns, and then we have a natural process that can develop these network of caves underground. Okay, we're in the right environment, we have the right kind of rocks, boom, you can have caves. And the thing about karsting is that it can extend for hundreds of miles, but I'll get to that in the next session. Because you can see in the map, right? I mean, we can go thousands of miles with these networks, and It's a really widespread event, especially if the carbonate formation is very, the original carbonate formation or limestone formation is extensive. All right, so last observation are the hot springs themselves, okay? And the hot springs themselves is like one of the things that everybody wants to theorize about. What's causing the hot springs, blah, blah, blah. Well, naturally, what I wanted to discuss is how they occur naturally and what we know can create hot springs, okay? So basically, hot springs can form when when we have these surface faults, okay? These faults breaking through the subsurface, okay, being exposed on the land. And then you have rainwaters or any kind of fresh water, say from rivers or from rain, coming in, and it basically goes down these faults, okay? These are really deep-seated faults, okay? And basically circulates, and then it hits a permeable layer, like a sandstone or whatever, and then circulates in that permeable layer, a deep permeable layer, that's very close to a heat source, say it's magma or whatever, okay? The water then basically heats up, and then warm water will start to rise, and it'll go up through fissures or natural cracks in the rocks to form these hot springs. So if it's a very, complicated, convoluted kind of network versus very low permeabilities, you basically get accumulations in the surface as hot springs. If it's a really big, thick conduit that's very close by to the heat source, you get these things called geysers, right? A good example of a geyser would be things that you see, Old Faithful in Yellowstone Park. It's a geyser, if you will, and it's full of hot water. Okay, it doesn't necessarily mean that there's a volcano down there. It could just be a deep-seated fault that's very close to a heat source. Okay, might have been a volcano down there. Okay, but it doesn't mean that it's a classical volcano, because classical volcanoes are things that are either expressed on the surface of the earth or, say, underneath water, right, or at the surface of the water bottom. Okay, so I mean it's just a very shallow heat source, if you will. Hawaii, this nice example of a hot spring that you see on the surface, right? This is a little accumulation. Okay, even looks like a little caldera if you kind of look at it closely from the Dumaveraria talk. And also, you also get these hot springs, that's forming in these little cave systems, especially in this karst topography. You can get local accumulations of warm water. Okay, like kind of see like these little caves in here that could serve as, that can be trapped. We're gonna have trapped hot water, if you will. And this is the, I can't even pronounce it, Guartagia hot spring in Iceland. And this is where actually that scene where Greta and Jon Snow first made love was filmed. So, it's really beautiful, really nice, clean water. Luckily, there wasn't a lot of sulfur in it, because a lot of these hot springs have sulfur, and it could be really deadly to you. So John and your Greg got lucky in this one. Just a fact, it could be pretty poisonous waters. So
they would have died in the arms of their love.
yeah. I mean, it's lucky that they didn't dissolve or anything like that in the waters. So to me, I really doubt that there's actually an active volcano underneath Winterfell, because it would have been observed, by seismicity. Okay, so there's no earthquakes being described around Winterfell, right? An active volcano would be associated with a lot of seismic activity. That's from the Dumaveraria talk from last week. So you would see earthquakes all over the place. Those things are never described in the books. You would see, potentially, a lot of dragonglass, a lot of obsidian being extruded. Okay, you don't see that near Winterfell. Okay, you might have stored caches of dragonglass material that the Chosen of the Forest or wherever, could have stashed there, but there are no natural deposits of dragonglass. Where you do see the natural deposits of dragonglass is in Dragonstone, and that isn't been described as a natural volcano, an active volcano. Okay, so there's nothing in the books that says that, okay, and there's no description that says that. I mean, what you can say is that there could be a shallow heat source.
Okay.
All right.
I'll take that. Yeah.
All right. You guys can prove me wrong if you want to, but I'm just going by what we know of how these hot springs form. And again, these hot springs can be sourced that could be originate hundreds of miles away. Okay, you don't necessarily need to have the heat source right underneath the place where the hot springs are. Well, all it takes is water coming in from 500 miles away, being heated up 300 miles away, and basically traveling through these permeable sandstone layers and then coming up through natural fissures in the subsurface. All right. Any questions on the hot springs before I head on to the big scale stuff, because this is the stuff that I'm the most interested in now.
I'd just like to say I'm really
okay. Yeah, cool. Okay, so the big picture, okay, and what I like about this is that now we're trying to reconstruct what actually happened at Winterfell and what's going on in terms of timing, because timing again is really, really important when trying to understand physical processes and what could be realistic and what cannot, and what isn't realistic. Okay. Essentially, here's a map of present-day Westeros. Okay, we have these black mountains right here. Okay, that I was talking about could be the source of the granite. Okay, we have Winterfell at the foot of the black mountains. Okay, you got the Wolf's Wood right there. All right. Basically, you have King's Landing about 700 or 1,000, 1,500 miles away, or whatever it is. Okay, number in our plate tectonics figure, right, we had a spreading zone that basically separates the Essos from Westeros, right, along the narrow sea, if you will. And we have the wall. Okay, now in terms of the actual observations in the books themselves and what George R. Martin has stated, he has stated that the wall is about 100 leagues long. Okay, that roughly equates to about 300 miles long. Okay. So right there's about 300 miles, that the length of that black bar. Now, assuming that there's a 1-to-1 scale on it, that means the length of the wall between the length of Westeros, assuming 1-to-1, is roughly about 3,000 miles. So you basically flip that black bar vertically and just basically count how many 300-mile long bars gets from the wall to Dorne, southernmost Dorne. So it basically stretches, from about 2,000 miles from north to south, and then at the widest point of Westeros, it's about 900 miles at the widest point, east to west. So now we have a concept of scale and distance, right? Now, in terms of the other features, so on Earth, right, we know that deserts appear within a general latitude range, roughly between 30 degrees north and 30 degrees south latitude. Basically the Sahara is the northern kind of within the 30-degree north band from the equator, and basically the Atacama Desert in South America is between 0 and 30 degrees south, right? So present-day Dorne, we know, is full of deserts, right? Because that's been described in the books. It's full of deserts. So now we could pin that latitude roughly at about 30 degrees, assuming that the relationships still hold true to Earth, like they are in Planetos, that, on Planetos, deserts form roughly around those same similar latitudes as Earth does. Okay, so we pinned it down there now. Now, the second anchor point now we have is we know that the ice wall has been there for millennia, thousands of years, right? So if it was in a more temperate environment, wouldn't that thing melt, right? So since it's been there for ages, and assuming that there's no magic involved keeping it frozen, okay, that we can probably suggest that it's probably in a permanently kind of frozen environment, or a permanently cold environment, if you will, right? The North is also described as being bitterly cold, so you can kind of maybe put the latitude of the wall roughly around close to what the present day Arctic Circle is on the Earth. Okay, it's permanently frozen, a lot of tundra, you know, the North Pole tundra, right? And so that's roughly about 66, okay, 0.5 degrees north latitude, okay? Okay, so basically what it means here is that, you know, if you just kind of take our scales now and just kind of basically look, you can kind of actually estimate what the length of, you know, how much variation of latitude that you have going from the wall to Dorne. And, you know, and it's about, you know, 3,500 miles north of variation. 3,500 miles of variation. So now I'm going to kind of step back here and talk about the whole idea about limestone now in Winterfell. We know that limestone also forms roughly, you know, between 30 north and 30 south latitude. Okay, so at one point, Winterfell must have sat somewhere along the 30-degree north latitude line. Okay, but now, since you know that's very close to the wall at 66-degree latitude, it's actually been shoved up, right? And now it's only 1,500 miles away from the wall, okay, or 700 miles away from the wall, or I forgot what the actual number was. So it needs to sit roughly about 60-degree latitude, okay? So if you just kind of take a ruler here and kind of measure the distance of how much distance it must have migrated north, how much distance the Winterfell site must have migrated from the time of deposition of the limestones to where it currently sits right now, we're looking at about 2,700 miles. Okay, yeah, it's really tough to for this to sink in here, but I guess the picture is that, you know, based on what we know of the rocks, the evidence, okay, we can kind of reconstruct where Winterfell sat, you know, when the limestones formed relative to what it is now and how much it's moved. Okay, the distance that it moved, which is roughly about 2,700 miles.
How many, those years, how many years would it take for something like that to occur around about?
Next slide. After the next slide, I'll show you. I mean, it's a big story now. Okay, now let's talk about rate now, right? Because everybody's interested in rate, because rate basically impacts the time, right? The time is basically dependent on the rate of movement. So if we went ahead here and just kind of looked at kind of like our different models here, I think the first thing that you see is that we had shallow seas and deposition of limestones around Winterfell some time ago. I don't know how much time ago, but we did have that. And that was in order to create the limestone. So we know that Winterfell must have been near 30-degree north latitude, or somewhere within 30 and 30-degree north and south latitude. Okay? We know that there's granite there. Okay? We know that, you know, there's a good source of granite in these big volcanoes, these big mountains that you see very close by. Okay? And in order to create these kind of mountain ranges, you're going to need some kind of subduction zone model, right? That we always talk about. That's been showing everybody for the past week and a half, right? So if you can picture a subduction zone happening between two different land masses, okay, so I kind of drew this little KL symbol showing, you know, where people think the location of King's Landing is versus location of Winterfell. What you can have is that you have an overall northward migration of these two land masses, okay? But then this King's Landing is kind of sitting on the oceanic plate and it's basically being subducted underneath the Winterfell plate, which is this. Okay, that's what happens, that you form these mountain ranges right behind the subduction zone, which is what these black mountains represent, and that's where you get the granite. So anyway, so in terms of how fast they're moving, well, we know that it takes about, present day plates are roughly 1 to 2 inches per year. Okay, I don't know what the rates were the same back then, but say they were the same back then. Okay, what that means is that it moves about a mile every 63,000 years. We do the math. Okay, and we know that the distance from the old Winterfell, where we were depositing limestones, to the present day location of Winterfell was 2,700 miles. You just basically multiply 63,000 times 2,700 miles, and that'll give you a time it takes. And that's what you get here. I mean, so basically, I did the little calculations. Basically, for all this stuff to move from Winterfell to go from roughly 30-degree north latitude to about now 60-degree north latitude, okay, that's roughly about 171 million years. So it's a very slow process, right? It's not like, you had this big catastrophe to all of a sudden reshuffle the plates around. We don't see that anywhere. So, and if it did happen, there'd be nobody left alive to actually tell the story. So basically, the whole process took about 171 million years. It could take longer. Still could be moving right now. It could have stopped, after 171 million years, and then it just kind of stayed still, until the present day. I don't know. Okay. But what we do know is that we got the rocks. We know that from the time of deposition of limestone to the emplacement of the granite, where the two continents probably collided, and it actually moved close to the present day, where Winterfell moved to the present day location on Westeros. It took about 171 million years. Okay, now at that point, when the granite actually formed, it was still kind of one big landmass around, that Westeros was connected to Essos. Now, it might have only took like another 25 or 50 million years now to basically separate out. And basically what happens here is that you kind of form a spreading ridge now. And now you have King's Landing, Westeros and Essos being basically pulled apart by this spreading zone, basically creating the narrow sea. And you can see that there's not much time, there's probably not much time involved between the placement of granite and where the present day Winterfell is, because it's only moving maybe about 500 miles north. So we're right here relative to 60-degree north. Now we're sitting at 60-degree north there. So 500 miles, that's maybe about 15 million years roughly or whatever. It doesn't sound like a lot of time, but there is. Yeah. That's all I'll say about that. So I hope that helps. I mean, that's kind of like what I think is going on, in terms of you get this limestone. We know that there's limestone there. We know that there's granite there. We know that limestones form in certain areas of the world. We know how granite forms. And I guess my last point was that once these limestones are actually exposed to fresh water, okay, then you get the onset of karsting. So the karsting could have been formed 100 million years ago or whatever, during phase 2, right, the middle picture, and it still could be going on right now. And and then this is where you start getting things such as water circulating through the system, getting heated up by some sort of shallow magma source or shallow heat source, and then you get the hot springs forming. That's Milt math right there.
So it's pretty much like it's kind of a slow moving play, big, and that's why it's not a lot of geological activity, but there's enough there to cause a hot spring or somewhere close by, right?
I mean, there is some type of heat source around that area. It doesn't necessarily have to be at Winterfell. I mean, Dragonstone's roughly around there, somewhere about 1,500 miles away, right? And that's our best evidence of a volcano, right? That's what's described in the books. Dragonstone has these big billowing, smoky mountains. Okay, and that's where we have the occurrence of naturally occurring dragon glass, which is basically volcanic glass, right? Very rapidly cooled volcanic material will basically cause dragonglass to form. So somehow in here, in this area here, if there's enough permeable rock, enough faulting, enough cracks, enough fresh water, and a good enough permeable reservoir to actually for the water to flow through, get close enough to the heat source, and then circulate back up to Winterfell, you can do it.
Yeah, I can see that.
Yeah, but it's very hard to throw around the term active volcano because again, we don't see any evidence of that active volcanic activity. We see no earthquakes. We don't hear about any earthquakes happening in Winterfell. We don't see, or it hasn't been described, any natural occurrence of dragonglass around Winterfell. Okay, so where's the active volcano?
Yeah, I mean, they did find it above the wall, but it was buried, so it wasn't a natural spot.
Exactly. Yeah. The children, the first, is the fist of the first men, right? The first men went up there with a bunch of dragonglass weapons, right? And basically just buried it north of the wall. It wasn't naturally occurring.
Yeah, so the volcano from Dragonstone could be affecting Winterfell, you're saying, right?
Well, I'm saying it's very tough because it's like 1,500 miles away, but some it could affect it if there's a network of magma, of shallow magma somewhere in the subsurface that you actually have these circulating fresh waters getting close to getting heated up and basically going back into Winterfell 1,500 miles away. It could, but just because there's a shallow source of magma does not mean that there's a volcano there. Okay, I guess that's the bottom line. You can have very deep faults that basically reach a magma source or reach a heated source, if you will. Okay, or any kind of source that basically emits heat. The waters will pass over top of it, get heated up, and then basically circulate back up through cracks and or other faults.
Almost maybe like a vein of magma or something.
Yeah, nature. It could be anything. I don't doubt that. I don't doubt that there could be some magmatic activity close to the surface, sort of like at Yellowstone, right? A Yellowstone National Park, right? I mean, as I was showing in the last slide pack, in the Valera talk, right? You have this chain of volcanoes, right? That erupted 16 million years ago in the first, and then it's basically migrating to the north, forming a chain. You can have extant calderas being formed, that has access to basically hot magma, and if the waters get close enough to it, it's like if the water is passing through the top of it, through these permeable layers, are close enough to it, they will get heated. And then the waters will just kind of flow up onto the surface around Winterfell. But again, an active volcano is tough to do. I mean, you would need like a lot of these extant volcanoes or ancient volcanoes. That's still somehow connected to a heated. That's still connected to a magma source.
Yeah. I got nothing, I think.
Yeah. So, so now we have timing and we have kind of like a model now. But this is my last slide, guys, and it basically tries to integrate everything together here. So, we got the Northern Mountains, okay, great source for granite. Okay, we got hot springs occurring around Winterfell. We got karsting underneath Winterfell, okay, aka the tombs, and this whole area, south of Winterfell or all around it, has was probably a source of limestone from way back, and you probably have these limestone quarries probably being built where they actually got the limestone from to actually make a lot of Winterfell, to construct the walls of Winterfell, the inner walls. the outer walls were probably from granite from the northern mountains or the Black Mountains, if you will. So everything's in proximity to one another. That's right. Yeah, and the caves underneath the Winterfells can be explained by by the expected subsurface limestone and karst process, right? Because we know that's probably underlain by limestone because we have a lot of limestone around there, and it's being exposed to fresh water right now. A bunch of rivers, right? All the water is percolating downward. Okay, you get a lot of rain. It's being exposed to a lot of freshwater rain, and and these hot springs, are probably due to some sort of superheated waters coming up through fracture systems, and these could be very deep-seated fracture systems that are getting close to a heat source and basically just circulating up.
Yeah, and not to mention the massive snow melt that they must have after each winter. That would be a lot of water going down, flowing through the...
Sure. Yeah, sure. Good point. I mean, I'm not exactly sure what the elevation change from north to south is, but it could happen. Yeah, because we definitely would need a gradient, but a negative gradient.
That's coming from a shy.
Oh, I don't know anything about botany. That's my answer.
That was a question from John St. Baptiste. I didn't know if you would know or not, but I figured I'd ask.
Nah, I know nothing. Jon Snow about botany. So,
Husky, have one other question. Do you know any real cities that are along the same parallel that Winterfell is? What is it, the 6th parallel?
Let's try to see something here.
Because it could...
No, I don't have a good map, unfortunately. Well, Bravo's at 50. Maybe Ib?
I think he was talking about real world, like historical sites, possibly.
You mean the real world?
Yeah,
okay.
yeah.
Oh, okay. Okay, that's the easier question. Okay, let's take a look here. So 60 is this line right there. Okay, can I see the dash right there? See my cursor? That's 60° north right there. Right, we got 30 and then we got 60. So I don't know, Anchorage perhaps could be one. In Norway, or Oslo perhaps. I don't know, maybe, I don't know.
So
let's go this way here. The northern tip of Japan, perhaps. Siberia, definitely.
the main race of people, ancient people that I can think of would be probably the Nordic people.
Mm-hmm.
At that, I'm trying to think of other, maybe Tibetan and other native. Well, I don't know if Tibet's lower than that, isn't it?
Mm-hmm. Oh, Tibet's down roughly in this latitude here. But I mean, latitude isn't the only factor for weather, right? Like you have predominant winds and everything else. That's one factor. Another factor is the natural terrain. We're not your sheltered. We're not. Even ocean currents play a role in weather.
Yeah, I'm trying to think. The cold crypts and hot walls. But I think we went over that earlier. Let's see. Yeah, I don't know if you want to. You can't see the chat, can you?
I'm looking at chat right now. Is there a question?
Yeah, Connie Super is asking about the cold crypts, hot walls, and the springs, and asking why. But
well, yeah. I mean, in terms of the cold crypts, go take a field trip to Carlsbad Cavern. It's pretty darn cold in there. Okay, I mean, there aren't any. You might have some hot springs in the waters themselves, but the overall environment, since we're underneath the ground, right? We're underground. It gets pretty cold as it get deeper and deeper, right? Underground from the sunlight. Hot walls. Go ask Brown the Builder. It wouldn't surprise me if he basically devised a plumbing system to leverage the hot springs, and that was able to circulate through Winterfell. Hell, the Romans did it. So, and if Brandon Builder is as cool as we think he is, then I don't see why he can do it.
Yeah, I agree.
Yeah.
It's always magic.
Yeah, or it could be magic. You know, it's probably why it only took him a couple years probably to build it. Or I don't know how long it took him. I'm just kidding. I don't know.
Maybe it was a composite character like many historical figures today.
Yeah, it could be.
Seems to hint at that at all the Brandons.
Yeah. You know, and the crypts are not built, right, before they pump water through the walls, right? The crypts are naturally forming, so nobody's building them, right? They're actually forming naturally. So.
You got anything, Mackenzie?
Well, not really, because it was like so engrossed in like conversation. But yeah, so we can kind of dispel the dragon theory a little bit, I guess. And I guess this is not really for this topic, but it's like we can do like a thing, I guess, for the Erie and how I guess that sort of thing makes sense, like the sky cells and all of that, like how they can build that as well, and like how that structure even makes sense because it's like such on a small, like in the show anyways, it's on like a small bit of like rock because it's like been like carved out, I guess. I don't know if I'm talking nonsense or.
I mean, Milt makes us all look bad.
No, I mean, I don't know how the area was built. Here's a little slide here showing that the present day geography, if you will, of Westeros. So in that right hand slide there, so basically you have that crescent, right? So that's the mountains of the moon, right? Shaped like a crescent. Okay, and the area is probably built somewhere, you know, somewhere at the base of one of these mountains. I mean, they build castles in, you know, I think there's some castles in Switzerland that are very close to the Alps. So, I mean, I don't think the area is like on top of a mountain, right? But it could be like in a pass or like in a little valley, you know, in between mountains, but still relatively high up in elevation versus the low-lying lands, right? So you could have valleys up there, right behind, right along the crescent, right along the mountains of the moons, if you will, and then relative to the actual vale part of the vale, which is in this little green area, right, which is the actual valley, you know, you could have like these mini valleys where they were able to build mountains. That's just an idea.
I mean, it makes sense. It's hard to know because we see what we see in the show, but the books, we get a certain description, but it's hard to know exactly what's going on there because you don't get as much of a description of the Erie as you do, say, Winterfell or other places. You just... I'm going to ask anybody in the chat have any questions for Milt while we have him here. I know Milt might want to say a few more things, maybe? Or you?
Oh, no, I'm done. I'm done with this stuff.
It's dropping the mic and out.
I mean, there's nothing more to say about Winterfell. You know, I mean, it's just, you know, one man's opinion, basically referencing other people's work and basically integrating some of the physical processes that we know on Earth right now, especially the rocks.
It makes a lot of sense, and you know, even if you're completely wrong, I learned a lot about geology.
Well, you know, we can at least explain it with natural processes as opposed to making a theory without any kind of support material or kind of working backwards and trying to make the observations fit your hypotheses. And if the observations are uninformed or wrong, then it's kind of a waste of time. So anyway.
I've did it before. I think it's a natural thing for people to do sometimes. Something you got to teach yourself not to do, because
Exactly.
Every human to want to make what you believe right, no matter what.
Yeah.
Yeah, I fully agree with that. I really appreciate you coming on, and try to give a shout out to the chat. Actually, I'm gonna let Mackenzie do it today.
All right, I'll do it.
Give her an open invitation.
So, and John C. Baptiste, his question was answered when he was not here, so we'll either have to let him listen back or Bill can say it again, which was about the ghost.
John. He's not a botanist. Milt gave us snark.
Which was about like the Essos and like grass kind of comment. So, but we have Connie Super, Bubba Husky, AU Pack Mule, the lovely Alamar, John C. Baptiste, Eduardo, Terry T, some guy named Johnny B. Crazy. Terry T, if I didn't say that already. What else? Dog Sidious.
We had Sanchi in the chat too.
Yeah.
So
Sanchez.
that's about it. I think a lot of people just listen. It wasn't like
Peter Griffin.
Oh yeah, Peter Griffin. Hey, Peter. Thanks for coming out, everyone. I really appreciate it.
Yeah, I'm looking at the chat right now. There are just a couple of questions. Any evidence for an unstable core inside of planetos? Well, I mean, if there was one, I think we'd be in a world of hurt on planetos. I think you have a lot of natural disasters. Some really wild. Some really wild orbits around the sun. A lot of earthquakes, probably a lot of seismic activity everywhere. I mean, it'll be very difficult to live on if it was that unstable. Let's see now. Why do you think the direwall is called what the castle was? I never heard that quote, Bubba. I can't answer that. Other than the fact that the crypts are naturally still being formed right now, right? It's being exposed to fresh water. Things are just being dissolved, so they are growing. So if the direwall is going to call that, define that as living, then so be it. I'm not a professor, but I am a professional geophysicist, so I do work as one. So, and I have a master's degree in geology. So, what else? Anything else?
Yeah. The best blanket maker ever.
I was about to say that.
Yeah, you just stumped me there, Milt, with your snarkiness.
That's the other side of my personality, right? So, yeah. I mean that's pretty much it. Are we doing outros here, or are we?
I don't know. Johnny just left for a second.
Okay.
My dog's gonna go crazy, so you're gonna hear some dog barking. I'm gonna say thank you so much, and I'll let everyone else sign me off because we got a problem here.
#ReFranco.
Okay, and remember tomorrow I'm hosting Pacific Trivia. We're gonna do trivia. It's not gonna be Jeopardy like usual for us. We're gonna do another type of format that we talked about really, really early on when we first formed the channel. And it'll be Felicia and myself. We're gonna go through the Targaryen kings and queens for one board, and the second board would be fire and steel. So check it out tomorrow at 8 p.m. Eastern Standard Time, or for you Europeans, it'll be GMT -5.
That's right. And I guess we're going to get out of here. I finally got the dog to calm down. Thank you, everyone, for coming out. And we'll catch you next time on Nooners of
Johnny,
Fire. Oh, what?
I didn't get to say bye.
Oh, I thought you did your outro a minute ago. That's my bad. I'm being very rude.
I get to sassy now. Well, everybody knows where to find me anyways, but I just wanted to promote, if anybody wants to come on Episode Club, they're more than welcome to. Just let me or Johnny or anybody know if you want to join in on the conversation. And that's about it. So, we can just sign off now.
Yep, take us away, Milt.
All right. See you guys later.